In the following video, we're going to examine how to solve a system of equations by using inverse matrices. So in this process, there are really three steps you need to do, and we'll use this video as an introduction. If you think of the equation 3 halves x equals 12, in order to solve for x, you need to multiply both sides by the inverse of the coefficient. So I'd multiply by 2/3 on the left side and multiply by 2/3 on the right side. And when I multiply a number by its inverse, remember what happens is you get the number 1. The product of a number and its inverse is 1. And so that allows us just to have 1x, x, and here x would equal 8. 12 times 2/3 is 8. So if you multiply a number by its inverse, you get a coefficient of 1. And we learned in our previous lesson, if you multiply a matrix by its inverse, you get the identity matrix, which the identity matrix is like our coefficient of 1 for matrices. And so we're going to use that idea, that if you multiply the left side and right side of an equation by the inverse of the coefficient, you're going to be able to solve the equation. And so let's look at this example with the system. We have 3x plus 2y equals 7 and negative x plus 7y equals 1. Well, the first thing you're going to want to do is you're going to want to create a coefficient matrix, just like what we've done before. So I have my 3, 2 for my x, y, and my negative 1, 7. And then we set up the equation. Now, when you set up the equation, because remember when you're multiplying, let's take a look at the system and our equation of matrices we set up. Our coefficient matrix goes here. Our x and y variables go as a column in a separate matrix. And the reason why is because remember when you multiply, here is a 2 by 2 matrix. And this is a 2 by 1 matrix. And so the insides match, therefore I can multiply. You would do 3 times x plus 2 times y. And that would be equal to 7. And if I multiply here, you get negative 1 times x, which is negative x, plus 7 times y, and that's equal to 1. And so we see I actually get my system of equations by using this setup. And so that's why we use this setup for it. And so let me erase this. So what you do is, we can even label it, set your coefficient matrix. And then what you're going to want to do is create a variable matrix. Use them as your columns, x and y. And then you're going to have your solution matrix. And solutions being what the two expressions are equal to. So you set up your coefficient matrix, and then you set up your variable matrix, and then your solution. So if we were to look back up at the equation example, it's just like the part where I have 3 halves x, we'll bring it down here, equals 12. We have our coefficient matrix, our variable, we have our variable matrix, is equal to our solution, and we have our solution matrix. So right now, this is where we're at with our matrices. And then the next step was to multiply both sides of this by the inverse. So we multiplied both sides by 2/3. And so that's going to be the process here. Instead of going to the work and finding the inverse for the just walkthrough example, I'm showing it to you. The inverse of 3, 2, negative 1, 7 is 7 23rds, negative 2 23rds, 1 23rd, and 3 23rds. And remember, when you multiply a matrix by its inverse, you're going to get the identity matrix. And so this identity matrix would be 1, 0, 0, 1, which is just like having your coefficient of 1. And then you're just going to do the math on the other side. 7 times 7 is 49. So 49 over 23, negative 2 times 1, so you get minus 2 over 23. And then 1 times 1 times 7, so you get 7 23rds. And then 3 plus 3 times 1, 3 23rds. And so remember, your identity matrix is just like your coefficient of 1. And we don't ever show coefficients of 1. And so then you just do the math. 49 minus 2 is 47. 7 plus 3 is 10. And so our x is 47 23rds. Our y is 10 23rds. And remember, the solution for a system is a point of intersection, is a coordinate. So write your x and y as a coordinate. So it's a lot trickier to see with matrices because you have all the numbers, you have the matrices set up, but the general rule is the same. You want to multiply both sides by the inverse. Now, one thing I want to point out as well is when we multiplied both sides by the inverse, notice that we did our front multiplication. Just like when we did rotations and we did reflections, we have our front multiplication by the inverse. And you have to apply that same technique. So hopefully this video will provide a little introduction to solving the system equations using matrices and inverses. And why don't we go through some examples together and see if it makes more sense.